Hello friends, today we are going to study the physical and chemical properties of amines. We are mainly going to study some important physical properties of amines. So, the physical properties of amines, the first property is basic nature of amines. Amines are basic in nature. So, why amines are basic in nature? To understand the basic nature of amine, you have to know what are acids and what are bases. So, according to Lowry and Bronsted, these are the name of scientists, the substance which accept proton or H plus ion is called base, and the substance which donate proton is called acid. You can see in the example when amines are reacted with water, the amines accept H plus ion or proton from water, and therefore nitrogen carries negative charge and hydrogen carries positive charge. As amines accept proton, they are basic in nature. Or we can explain in by using another theory, that is Lewis theory. According to Lewis theory, the substance which donate lone pair of electron is base, and the substance which accept lone pair of electron is called acid. So in amine, nitrogen contains lone pair of electrons, which is shown by two dots on nitrogen. And when these amines are reacted with HCl, nitrogen donates its lone pair of electron towards chlorine, and the product form is RNH4 plus Cl minus. So the lone pair of electrons are transferred from nitrogen to chlorine. Therefore, amines are basic and hydrochloric acid are acids. So by using these two theories, we can explain the basic nature of amine. Many times questions have been asked in board question paper. That is, explain the basic nature of amine. There are mainly three theories which clearly defines acids and bases. The first theory is Lowry and Bronsted theory. According to Lowry and Bronsted, the substance which accept proton is called base, and the substance which donate proton is called acid. According to Lewis theory, the substance which donate lone pair of electron is base, and the substance which accept lone pair of electron is called acid. There is one more theory, that is Arrhenius theory. According to Arrhenius theory, the substance which gives H plus ion when dissolved in water is called acid, and the substance which gives OH minus when dissolved in water is called base. You can see in the first reaction also, when amines are dissolved in water, they produce OH minus ion. Therefore, this reaction can be also explained with the help of Arrhenius theory. So this is the first property, that is basic nature of amine. Now the second and very important property is intermolecular hydrogen bonding. In amines, the N and H bond is polar bond. Nitrogen carries partial negative charge and hydrogen carries partial positive charge. This is because both nitrogen and hydrogen have difference in their electronegativity. Nitrogen is more electronegative, therefore it attracts electrons of hydrogen towards itself. Therefore, nitrogen carries partial negative charge denoted by minus delta charge, and hydrogen carries partial positive charge denoted by plus delta charge. And due to polar bond, the first degree and second degree amines, that is primary and secondary amines, they form intermolecular hydrogen bonding. You can see in the example there are four amine molecules. The first amine molecule, the hydrogen carries partial positive charge. It gets attracted towards nitrogen of another amine molecule. Same way, the hydrogen of second molecule gets attracted towards nitrogen of third molecule. and this dotted line is called hydrogen bonding. So in amines there is a hydrogen bonding between molecule which is called intermolecular hydrogen bonding, but tertiary amine does not form hydrogen bonding because tertiary amine does not contains NH bond. We have already seen the structure of tertiary amine. In tertiary amine only nitrogen is present but there is no hydrogen atom, and therefore intermolecular hydrogen bonding is absent in tertiary amine, but it is present in primary and secondary amine. So this is the second physical property of amines. Now third physical property of amine is solubility. Again reason is same, due to polar NH bond amines forms hydrogen bonding with water. When amines are dissolved in water, they are soluble in water because the oxygen of water molecule gets attracted towards hydrogen of amine. You can see in the structure, this is first H2 molecule, oxygen is formed hydrogen bond with amine. Similarly, one more water molecule is on the right side. Oxygen carries partial negative charge, hydrogen carries partial positive charge, and there is a weak van der Waals force of attraction which is called hydrogen bonding. So the lower amines are soluble in water, but their solubility decreases with increase in molar mass. So methylamine, ethylamine, propylamines, they are soluble in water, but if we go on higher molecular masses, that is butylamine, pentylamine or aromatic amine, they are insoluble in water because when molar mass increases, number of hydrogen atom increases, the tendency to form hydrogen bonding decreases, and therefore they are insoluble in water. But lower members of amine, that is methylamine, ethylamine, they are soluble in water. So for any solubility question, if question is asked why alcohols are soluble in water, the answer is same. Lower alcohols form hydrogen bonding with water and therefore they are soluble in water. Now fourth property is boiling point. Again the reason is same, polar bond, NH bond, intermolecular hydrogen bonding, and therefore first degree and second degree amines have higher boiling point than corresponding hydrocarbons, whereas tertiary amines have lower boiling points because tertiary amine they does not form intermolecular hydrogen bonding and therefore they have lower boiling point. If a substance contains intermolecular hydrogen bonding, its boiling point also increases. Amines have higher boiling point than hydrocarbons and lower boiling point than alcohols of comparable masses. That means a 50 molecular mass of hydrocarbon is compared with 50 molecular mass of amine, then amines have higher boiling point than alkane, but if amine is compared with alcohol of same molecular mass, then it is found that amines have lower boiling point than alcohols. You can see in the following table, the primary amine having molar mass has a boiling point of 350.8 Kelvin. Secondary amine it has 329.3. Tertiary amine have boiling point 310. If the same molecular mass of carboxylic acid, it has a molecular mass of 414, or same molecular mass of alcohol, it has a molecular mass of 390. So by this table we can see the lowest boiling point compounds are hydrocarbons, then second is amine, they have slightly higher boiling point than hydrocarbon, Then third one is alcohol. Alcohols have higher boiling point than amines. And fourth one is carboxylic acid, because carboxylic acids have more higher boiling point than alcohols. So these are the four important physical properties of amines. Now let us study the chemical reactions of amines. The first reaction is Hofmann's exhaustive alkylation of amine, or it is also called Hofmann's exhaustive methylation of amine. So when primary amine is reacted with alkyl halide, the one hydrogen atom and halogen gets eliminated and the product formed is secondary amine. When secondary amine or second degree amine again reacted with alkyl halide, tertiary amine is formed. And when tertiary amine again reacted with alkyl halide, a tetraalkyl ammonium salt is formed. This tetraalkyl ammonium salt is called quaternary ammonium salt. So question might be asked, what are quaternary ammonium salt? So answer is, the tetraalkyl ammonium salt is called quaternary ammonium salt, in which nitrogen is attached to four same or different alkyl groups. We can see in the example, when methylamine is reacted with methyl iodide, one hydrogen and iodine gets eliminated and dimethylamine or second degree amine is formed. Similarly, when dimethylamine is reacted with methyl iodide, trimethylamine or third degree amine is formed. And when third degree amine is again reacted with methyl iodide, tetramethyl ammonium iodide, which is called quaternary ammonium salt, is formed. So what is quaternary ammonium salt? Question have been asked in the exam for 1 mark. Answer is, tetraalkyl ammonium salt is called quaternary ammonium salt. It is represented by R4N plus X minus. Now the second chemical reaction is acylation of amine. When primary amine is reacted with acetyl chloride CH3COCl, then N-ethyl ethanamide is formed. N-ethyl ethanamide is formed. What is amide group? NHC double bond O group is called amide. Therefore, the product name is N-ethyl ethanamide is formed. If second degree amine is reacted with acetyl chloride, again hydrogen and chlorine gets eliminated and NN diethyl ethanamide is formed. So the elimination of hydrogen and chlorine takes place. But if the same reaction is for triethylamine, when triethylamine is reacted with acetyl chloride, there will be no reaction because nitrogen does not contains any hydrogen atom. Therefore, no elimination of HCl. Therefore, no reaction takes place. So, in today's lecture, we will see only these two reactions. This is for your homework. If C2H5NH2 is reacted with excess of C2H5i, what will be product? And if C2H5 twice NH is again reacted with methyl iodide, what will be the product? So this is your homework.